But this is another part, means Ostwald dilution law coming under the ionic equilibrium. After the theories of acid and bases, now we are discussing about Ostwald dilution law. But Ostwald dilution law, let us say I am having one of the soluble salt like a AB, it is in aqueous medium. It is having cation and it is having anion. Let us say initial concentration of this one is C, and here it becomes a 0 and 0. Out of C, X mole dissociate, X mole form, and suppose the concentration is given here. Suppose concentration is given here. C concentration of X dissociated, C concentration of A will form, and C concentration of B will form. So if you apply the law, if you want to write the equilibrium constant K here, that is equal to concentration of the cation into concentration of anion by the AB. Concentration of cation C into X means we can say it is a C alpha and C alpha. Alpha is called as a degree of dissociation, that is called as a DOD. C alpha into C alpha by C minus C alpha. C alpha into C alpha by C is common, 1 minus alpha. C and C get cancelled. C alpha square by 1 minus alpha. So we can write the formula K equal to C into alpha square by 1 minus alpha. For weak electrolyte, for any weak electrolyte, degree of dissociation will be very, very less than 1. So 1 minus alpha, which is at the denominator, can be taken as a 1. So we can write C into alpha square. Alpha is called as a degree of dissociation. C is called as a initial concentration. That means you can see by seeing this formula, we can say alpha is equal to alpha square equal to K by C. Alpha equal to under root of K by C. C is a concentration. Concentration is equal to 1 by V. That means concentration and volume are inversely proportional. So we can say alpha equal to under root of V. That means as the dilution increases, as the dilution increases, alpha degree of dissociation also increases, because dilution increases, here volume increases, alpha also increases. Based on that, we'll see the application of the Ostwald law. What are the applications of Ostwald law? Listen here. Application of Ostwald law. It will be used to calculate the dissociation constant or concentration of H plus ion, or we can say it is used to calculate concentration of H plus ion. or concentration of OH minus ion or Ka or Kb or alpha. One example I'll tell you here. Calculate concentration of H plus ion in a solution of 0.2 molar acetic acid if dissociation constant value of K is given 1.8 into 10 to the power of minus concentration of H plus ion and calculate alpha value. So we have to calculate alpha as well as the concentration of H plus ion if K is given 1.8 into 10 to the power of minus 4. So as we know that alpha equal to concentration of Ka by C, right? So now formula we are writing this way कि acetic acid when it is going to ionize, it ionizes as a acetic ion and H plus ion. Concentration of acetate ion is acetic acid given as a 0.2 molar initial. It becomes 0 and 0. Now, as we know that C minus C alpha, it forms C alpha, it forms C alpha. So we are able to write the value of Ka equal to C into alpha square by 1 minus alpha. We know the value of Ka. Value of K is given as 1.8 into 10 to the power of minus 4. That is equal to concentration given as a 0.2 molar into alpha square, and this 1 minus alpha will be taken as a 1, so it will be neglected. That is only 1. On solving this one, we can get alpha equal to 1.8 into 10 to the power of minus 4 by zero point 0.2. You solve it, value of alpha, which one I got 3 into 10 to the power of minus 2. But you know, concentration of H plus ion is equal to C into alpha. We are getting from the equation. As we got the alpha, now we can say concentration of H plus is C into alpha. Value of C zero point 0.2. Alpha is 3 into 10 power of minus 2. So it become a 0.6 into 10 to the power of minus 2 molar is a concentration of H plus ion. So we got concentration of H plus ion as well as the alpha. So this is a simple question they give. But now one more question based on this part. Now they are asking calculate the concentration of acetic acid in which concentration of H plus is 1.5 into 10 to the power of minus 3 molar. If K is given 2.6 into 10 to the power of minus 3. In previous question, concentration of acetic acid they gave, K they gave, and they asked to get H plus. Now exactly different order. K they give, H plus they give, and they are asking concentration of acetic acid. Now how to get here? Same way. This is the acetic acid. It will be converted into acetate ion and H plus ion. So we can say in this way, K equal to concentration of acetate ion into H plus ion by acetic acid. If you know concentration of H plus ion is given, this is a value given at equilibrium. So we can say concentration of H plus ion is 1.5 into 10 power of minus 3 means acetate ion value also the same thing. So now apply the formula. What is the value of Ka they gave? 2.6 into 10 to the power of minus 3 equal to concentration of acetate ion 1.5 into 10 power of minus 3 H plus 1.5 into 10 power of minus 3 by concentration of acetic acid. Now just you solve it. By solving this one, answer which one I am going to get here as a 1.5 by 2.6 into 10 to the power of minus 3. That is 15 by 26. 3 5s are and 3 lines are means 8. 5 by somewhat 8 point something will get 1 by 2 0.05. So approximate answer which one I am getting here 1.5 by 2.6 into 10 to the power minus 3. And if you solve this value, by solving this value which one I am going to get nearly 1.5 by 2.6 by 1000 also if you do 5 into 10 to the power of minus 4 molar, it is approximately 0.00057 molar. So this is the answer we are getting. Concentration of acetic acid. These are the two applications we did here, right? Based on the Ostwald law.